Okay, so today we want to look at what we call hierarchical component models in PLS. So far, what we have been doing, it's more of something what we call lower order constructs. So we want to look at advanced PLS-SEM regarding that we can perform. And this is what we term as hierarchical component models applicable in partially spread structural equation model. It is also termed as higher order constructs, HOC. So what is the rationale? What is the concept with higher order constructs? I don't know. Do you get feedback? Do you hear any sound from my background?
From my end, it's okay.
Lovely.
Oh, okay. We have a lot of Ghanaians. That's let me have a class so that we can. Okay, thank you. So the concept of higher order construct. So a higher order construct represents a broad concept that is examined at a more abstract level, together with its underlying dimensions. So it allows you, the researcher, to model a general concept. And if this concept has specific dimensions within the same underlying general concepts or abstract idea. Okay. So the higher order construct captures the overall meaning of the concept. And then the lower order component represent its measurable concrete dimensions. Okay. So the structure makes it possible to analyze relationship at two different levels. That is the overall construct and the overall construct in the structural model, and then the individual dimensions in the measurement model. So here, instead of you treating each dimensions as independent constructs in the structural model, we organize it under we organize the lower order construct under one overarching concept. So let's look at some example. The first example is, let's think about what you call reputation of a university. So when we talk about university reputation, there are a lot of things that come into play, through which we can see that, yes, this university has a very high reputation, or maybe we can rank it high. Okay. So it means that for us to talk about a broader idea or concepts about what university reputation is, we have to consider sub-dimensions. So one of them is that we can look at teaching quality. So teaching quality is a distinct, it's a concept or a broader concept which is or which comes into play when we are looking at university reputation. So another one is research performance. So we can look at the research aspect of the university and how they perform. Are they really doing well in research? Are they publishing and all? And then we can also look at infrastructure. We look at the facilities that university has. Do they have computer facilities? Do they have laboratory facilities? Do they have dormitories? Do they have enough lecture halls for the students? We can also talk about graduate employability. Okay, so when people finish this university, do they have higher chances of being employed? So if you look at most of the universities websites on from the United States of America, you realize that most of these universities report on graduation rates and then employment rates. I don't know for Ghanaian investors, it's not really common. I've not seen some, but in the US, it's very common. Each school has graduation rates and then employment rate. They even sometimes mention the alumni on their platform, where most of their alumni are, most of them are after school. Okay. So this together helps us to assess. There can be more, but what we have here are sub-dimensions of what make up university reputation. Okay, so let's look at another example. Healthy lifestyle. So if a person becomes more healthy conscious or more health conscious, there are other aspects that we can consider. Okay. So the overall idea that we are looking at here is healthy lifestyle. And it can include a sub-dimension called exercise. So somebody will have to do some exercises, and then exercise is a sub-dimension of healthy lifestyle, such that we can also measure exercise on its own. So for example, we can say that, or one of the indicators that we can mention, or whilst we are setting the question, we can say that maybe I exercise at least 3 times a day, or maybe 3 times a week. So this is a sub indicator. It's an indicator of somebody who exercises, right? You can also mention that maybe I engage in physical activities for maybe at least 40 minutes every single day. That is also an indicator of what we call exercise. So this is an engagement. You can also see that maybe I stay physically active even on busy days. So all of these things are indicators that are correlated to each other and underline or together underlines the concept exercise. And exercise is a sub-dimension of healthy lifestyle. In the same way, you can set questions on diet, sleep, stress. So for diet, we can say that maybe I eat fruits and vegetables every single day. And then the person will have to take from the questionnaire. Strongly agree, strongly disagree, and so those kind of things. I limit my intake of sugary and then maybe fried foods. Okay, so all of these things, all of these questions are questions that are measures for diet. For sleep, you can say that maybe I sleep at least maybe 7 hours each day. I wake up maybe feeling rested and refreshed. So this indicates that this person has been enjoying some kind of sleep. The person will have to take the same way stress. The person can say that maybe I feel calm and relaxed most days. So all of these things are indicators for stress and manage maybe pressure without feeling overwhelmed. All right, so that is it. Now, the key point is that the overall concept drives the dimension. So these exercise, diet, sleep, and then stress are the sub-dimension that drive healthy lifestyle. And based on our knowledge that we have learned before, you can see that healthy lifestyle, which is the higher order construct with its sub-dimensions, which is exercise, diet, sleep, and stress, is a reflective, right? Based on what you have learned so far, this is a reflective. Why? Because the healthy lifestyles, the arrows are pointing towards the sub-indicators. So in that case, this is reflective model, all right? In the same way, we can have a logic where we now invert our arrows into healthy lifestyle. So now this is what we call formative. So healthy lifestyle is a higher order construct. Let's not view it as dependent variable and then these are dependent independent variables. We are talking about this as the higher order construct. So it means that there will be other construct that will be in front of this. So exercise, diet, sleep, stress. If the logic is that each of the factors contributes a unique part, in that case, it is going to be a formative model. Okay, so here a person may sleep while a person may sleep well, but not exercise. So it means that each of these are playing or they are having independent role. Okay, most of the times with formative constructs, the dimensions or the indicators have the extent to go. So it can be that the person may have a very good sleep, but the person might not have been engaging himself or herself in uh, good dietary food or something like that. So the logic can be formative in this aspect. So all of these depends on what you want to do, and then your rationale, your theories behind the result that you want to focus. Now, types of higher order constructs. We have four types of this higher order constructs. We have the reflective model. So we can see from here the higher order construct here, G, is reflecting to the sub-indicators. Okay, so it means that D1, D2, D3 are the lower order constructs and they have some kind of correlation. They relate to each other. They underline the same constants. Meaning when I take away the D1, the rationale behind my G will still be there because we have learned that with reflective, even if you take away an indicator, still the rationale behind your construct is valid. All right. It does not spoil or destroy anything. So with this higher order construct, the sub-indicators or the sub-dimensions are the D1, D2, D3. And each of these sub-dimensions have its own indicators that measures it. So that is A1, A2, A3, A4, sorry, A1, A2, A3, B1, B2, B3, and then C1, C2, C3. So let's look at the type 2. The type 2 is the reflective formative. So the reflective begins with the sub-dimensions. So this is reflecting to the indicators A1, A2, A3. Same way, D2 is reflecting to B1, B2, B3. But the sub-dimensions come together to form the higher order construct, which is the G. So this is the type 2 uh, type of higher order construct. And type 3 is formative, so it means that the sub-dimensions come to form the sub the indicators of the sub dimensions come to form it. And then the sub dimensions are now being reflected onto the higher order construct. So this is the formative reflective model. That is a type 3. And type 4 is the formative. So it means that here the sub dimensions are being formed from its indicators. So A1, A2, A3, B1, B2, they come to form the D1, D2, D3 respectively. And then together, the D1, D2, D3 as indicators of gene come to form the gene. So these are the four types of higher order constructs in SEM. Now, under what circumstance do we go in for a particular type? Or when do we choose reflective higher order construct, and then when do you go for formative? It's the same as what you have done previously. So start with the theory. What is the rationale? What theories inform your decision to go for the reflective or formative? We have learned that most of the times social sciences field, most of the times we normally have the case of reflective, especially if you use questionnaire, right? You set similar questions and all of that. Most of the time you go in for the reflective. So you don't use statistics, you go for a theory. So you can ask yourself, does the general construct cause its dimension, or do the dimensions define it? So when you find an answer to this, that is where you decide whether to go for reflective. So for example, let's look at a higher other constructs, for example, customer satisfaction. So customer satisfaction can be grouped or can be decomposed into service satisfaction, product satisfaction, price satisfaction. So a customer can be satisfied based on the fact that the service that was being provided to him or her is what he is satisfied with, or the product, or maybe based on the price. All right. So here the logic is that when overall satisfaction rises, all three ratings tend to rise together. So this is a reflective higher order construct. All right. The second example is that it aligns with formative higher order construct. So I think we have used this example previously, socioeconomic status, and we mentioned that socioeconomic status is formed by three different sub core sub dimensions. So that is formed from income, education, and occupation. And once you take away one of these dimensions, the underlying concept for socioeconomic status is not the same. All right. So just as I've explained it in the diagram here, higher correlation among dimensions support a reflective structure, but did not prove it. Okay, so let's look at some of the conditions that informs our choices statistically. Okay, so you can test for high correlation among these dimensions, whether there is high correlation among these dimensions or sub-indicators of the lower order construct. But that is not a proof that you go for reflective or formative. But basically, low correlation may suggest formative modeling. So if there is a very low correlation among the indicators, the suggestion is mostly that it is more likely that the indicators are formative in nature. And that is especially if the dimensions are conceptually distinct from each other. All right. So it can be it can be that they have a very low subdimensions. The correlations are very low, but conceptually they are not different from each other. So for reflective dimensions, internal consistency measures such as Kumak alpha or composite availability are still relevant, and the threshold remains unchanged, which is 0.7. All right. For formative dimensions, internal consistency is not required. So here we focus instead of multi-collinearity and indicator relevance. All right. So let's take note of that. For formative dimensions, internal consistencies are not required. Now, with regards to multi-collinearity and higher models, when several dimensions are strongly correlated, include all of them separately in the structural model. Including all of them can cause the structural model to inflate, or it can inflate collinearity. So if there are the subdimensions or the indicators are correlated to each other, it means that if you include all of them together, it can cause the collinearity to increase. A higher order construct can summarize correlated dimensions into broader variables. So this is where the higher order construct comes into play. It helps to address the issue of higher correlations. So for formative higher order models, we have to check for VIF among these dimensions. So if VIF is below 3 or maybe 5, it is generally accepted. Right. For smart PLS, normally it is basically supposed to be below 3.3. So if VIF is high, reconsider indicator specifications or dimensional structure. Um, so now what is the advantage what is the advantage of higher order constructs? It helps us to reduce the number of parts in the structural model. So realize that whenever you are working and then the constructs are the construct or the latent variables are too plenty, they are too many, and they are clustered, you can group them into its subdimensions, and it helps to reduce the number of parts in the model. It improves clarity of the theoretical interpretation, right? So once you have your theoretical underpinnings, it helps to improve clarity. What do you want to achieve by the end of the day? It handles conceptually multidimensional constructs more realistically. So if there's a concept of some multidimensional construct, just as the one that we have looked before. For example, healthy lifestyle, which is having some dimensions with diet, talking about diet, talking about sleep. So all of these things are they are conceptual multi-dimensions of what we call a healthy living or healthy lifestyle. All right. Maybe somebody also have to add money to it. If you have money, some people see money as part of maybe healthy lifestyle. So maybe you can also add money to it, depending on what you want to achieve. It aligns empirically, it aligns empirical models with how complex structures are defined in theory. Okay, so that is it. Now, let's look at the practical sessions. But before that, are there any questions so far based on what you have learned right now? There's some questions. Okay, so if there are no questions, then
Yes,
okay, go ahead,
yes,
please.
yes. I want to find out how different is this hierarchical construct different from the uh, pattern loading principal component analysis, selecting the best value to use for the model.
You want to know how this concept is different from factor loadings.
Yes. Yeah, principal component approach where you use a factor loading to determine which of the variable is best used.
Oh, okay, so with factor principal component analysis, that is where if we have too many variables and then you want to know or you want to reduce the dimensions. Okay, so it is called dimension reduction. Yeah. So with if we have too many constructs or too many factors that you want to know which ones are highly relevant, that is where you do this principal component analysis. So you know the relevant factors that come into play. But with what we are doing here, we're talking about having a theoretical understanding of what you want to achieve. If your study, I mean, it has sub-dimensions, all right? Just as the one that you have looked at before. It can be that you are looking at a broader concept, but this concept has sub-dimensions. And for that matter, it is always best to go in for higher order constructs because it makes it improves clarity of what you want to do. All right. Yeah. So that is why you go in for um, the higher order constructs. So basically, if what you're looking for, you're looking at a broader concept which also has sub dimensions. In that case, you go in for the higher order constructs in SEM. But with fact, the PC that you mentioned, that one is even a measurement approach. It's not a structural approach. Okay. So we just want to know or review the dimension, the factor dimensions of the study. So you just run it. And I think that one is even in Smart PLS. Maybe let me show you that quickly. With the updated versions of Smart PLS, you can do principal component analysis. And it's very simple. Once you have uploaded your data, you just click your model. And then, so I think this is what we did the last time. This was where we ended. So you just come to calculate. And then you see principal component analysis here. Okay. You can even use this one to also check for your Hemans factor. Okay, that is used to assess common method variance or common method bias. So let me start calculation. I don't know if your question is answered, Mr. Mauli, if you asked the question. So these are the components. So far we have 28 components, and this is the eigenvalue. So I don't know why my laptop is very slow. Okay. Okay, very good. So these are the eigenvalues and then the variance proportion. So if you have some knowledge about PC, you realize that the first factor yields about 28.6%. And then the second component yields 14.4. So cumulatively, we have 43. And then the third yields 12%. So in total, we have 55.7. So with Haber's factor, you can report on this first value, right? So the first component yields 28.6, which is less than 50%. So according to Haber's factor, so far as you have less than 50%, you are good. I mean, it means that common method bias is not really a concern. But Haber's factor also has its own limitations. Okay, so there are other methods to grow. We have Podolsky 2012. You can also read about that. Um, I think there are other ways to check that. I'll research that and then maybe when we meet tomorrow, we'll go through that. So I don't know, is the question answered now? So here you have the screen plot.
Yes, it's answered. But what I know, okay, maybe
Okay,
basically
go ahead.
for with the eigenvalues, the
Mm-hmm.
ones above 1 are
Mm-hmm.
good to go. But looking at the values you had here, I think we are having about 5 components. So those are the 5 things that we can put to you. That's my understanding, basically,
Oh, okay, that's
for
fine.
my
Yeah, so
analysis.
it ends here. It ends to the fifth component because this is the ones that are above 1. So the
Yes,
eigenvalues are
yes.
yes, very good. That is right. So you can also report on the variance proportion as well to assess your um, common method variance or common method bias. That is it. You just copy from here and then you're good. You can also use SPSS to do that as well. So that is it.
Yeah, Doc.
Okay.
Hello, Doc.
Yes, please go ahead.
Yes. I think I saw in a paper using the reflective model, but it
Mhm.
was termed a second order construct. So is it different from the I don't know because in the paper they called it a second order construct, but
Oh yeah, yeah.
the
Okay.
model reflective model.
Yeah, so the other name is second order construct, all right? So it's either higher order construct or second order construct, the same thing. Or lower order construct or first order constructs. So if you don't hear lower order construct, you can also hear first order. If you don't hear higher order construct, you can also hear second order construct. So the same thing.
Mm.
We can also have third order
Okay.
construct as
Thank
well. Is there any other question? Okay, so if there are no questions, then we can go ahead. So let's use our data to practice. Well, let me see if I have any data.
So yeah, look.
Okay.
So I think that we can see various type of the hierarchy model that you have shown us earlier
Yeah.
on here.
Mhm.
Because I can see reflective, formative, and the next one is called.
Are you talking about what you see on the screen right now?
I think knowledge from here to the construct the construct that the practical one you wanted to show. I can see reflective, formative in the practical one that we did.
Oh, okay. Let me check that. Okay, so which one is the reflective and which one is the formative in here? Are you talking about this, the one that we did here the last time?
Yes, yes,
Okay,
yes.
so which one do you think is the formative?
I said reflective, formative. So when from behavioral to academic outcome, and from digital access to academic, platform quality to academics, and the one beneath to the academics. We see that now.
Okay. But previously, what we said was, we said that it was a mediator, right?
Reflective, yeah, yeah.
Okay. Okay, so you think that this is also a higher order construct, right?
I didn't get a question.
I mean, are you saying that this is the behavioral engagement here is a higher order construct? Okay, so
No,
if I
I'm
understand
talking
what
about
you
academic
mean,
outcome.
okay,
Academic
Think
okay.
outcome.
no.
Okay.
Academic outcome here. So, okay, based on what we did the last time, we said that academic outcome is our dependent variable, right? Because these are our independent variable and these are mediator. So this is our academic outcome. So let's say you want to convert this one to a higher order construct. Okay, based on what you have done. It means that we have to conceptualize such that you have a higher order idea or concepts such that the dimensions can be digital access, platform quality, learning support. So let's brainstorm and think about this. So do you think that there is a broader idea such that we can have its sub dimensions to be digital access, platform quality, and then learning support? Mhm. You can even include behavioral engagement as part of it, the sub dimensions. So anybody with an idea? Uh-huh. Okay, so let me think to, can we say that there is a higher idea, there is a broader concept called maybe institutional quality, and that institutional quality has a sub-dimension called digital access, platform quality, learning support. Does anybody agree with me or has any different concepts, broader idea that can bring up? So that means we
Do
all
you say
agree, right?
institutional quality or educational quality?
Well, educational quality is also good, or institutional quality. What do you
Okay,
think? Which one
I
do you
think I
think
agree.
we should agree with? Are you going for educational quality or institutional quality?
Um,
Mm-hmm. Miss
I
Sharon,
think
which one
either
should
way goes. I think either way
either way
goes,
goes?
but
Okay,
I'll
that's
go
good.
for institutional. Yeah.
Institutional quality, that is fine. If anybody has any objection, the person can bring it up and then we discuss. We are just discussing this together. Okay. That is where the theoretical reasoning comes in. So what does the theory tells you? Why do you think that when you do it this way, do you think that what you are trying to do does it have sub dimensions or not? So this is the theoretical reason that we always talk about. So now if I have, so for now, let's begin with the first one. That is the reflective model. Okay. So now, I don't want to clean it so that we have to start afresh. Or should we start afresh? I wanted to just clean the lines here so that we don't have to go back to what we have done before. So I already have my subdimensions, but ideally, you can just create your latent in here and call it maybe institutional quality. So based on what we are discussing right now, we are saying that institutional quality has a broader is the second order construct which has its subdimensions called digital access, platform quality, and then learning support. So what do? We just have to connect it. Don't forget that we are doing reflective model. So what are we going to do? You're going to connect this backcourt, and then we connect this one to academic outcome. But what do you see? We still see that there is a red in here, right? So with the higher order constructs, one of the very first method that we have is what you call a repeated indicator approach. Okay, so how do you go about the repeated indicator approach? We first assess the subdimensions. So this is we just have to model the first dimensions, and then each of the values in here, we repeat it or we bring it into the main higher order construct. Okay, so we have D1, D2, D3, D4, and D5. So what do? We have to repeat it in here in the main or the higher order construct. And then we have P1 to P6. So let's see P1 to P6. We copy that and then drag it into institutional quality, which is the second order construct or the higher order construct. And then we have learning support. So this is it. All right. So I'll just have to run it and then see if I have what it takes. So what did we see here? So this is where we ended. The lower order constructs are reflective, so the higher order construct is also reflective. So this is the reflective model. Indicators reflect their respective dimensions. So indicators here, these are the indicators. They are reflecting these dimensions here. And then the dimensions here becomes indicators for the higher order constructs. Okay, that is it. And then, so what do? First, we have to assess the lower order construct. Don't forget that we have two main approaches to go by our assessment. We have the measurement approach and then the structural approach. So first, we check the indicator loadings, we check the internal consistencies using Chromback Alpha and then composite reliability. We check also for convergent validity using AVE and then discriminant validity using ATMT from a local or maybe cross loadings. All right. So now we have run this and let's check our lower order construct, the measurement model. So you can see from here that it has been met, right? R square okay. I think I'm seeing something here. Let me see. So if you see R square here, it means that the institutional quality is predicting digital access. And then this is also predicting that, this is predicting that. So let me go back to my model. I don't know, I'm sure because of the data, how we conceptualize it. So let me come back here and make a copy. So let's duplicate. Let's check our data sets. Is it this one? This one. So let me select the entire. Let me see. So let's say we have the data access, which is DA. Let's say we have platform quality. And then we have academic outcomes. And then we have the higher order construct, which is DA to D. So let's call this one institutional quality. And then you have what else? Platform quality. So platform quality here. Okay, so I think this is how it's supposed to be. So let's connect it this way. Okay, so this one is a reflective model, right? We are using the repeated indicator. So the DA is a reflection of the digital access, and then PQ is also a reflection of platform quality. And because we are repeating these values into the higher order construct, the reflective is seen here. The reflective aspect of the two dimensions are seen here. So assuming that we take this one inverse, when we do this one this way, in this case, we are looking at reflective formative construct. All right. For the repeated indicator approach. So here we have reflective formative. Now, if I invert it, we have reflective, reflective, because the reflective is seen in here. The INQ is moving towards this one, the D1, D2. So this is the reflective approach. What I did earlier was that I moved this one backward this way. And when it happens this way, it means that this one is actually predicting that. So anytime you see this value, that is the R square. All right. So the right way is let's revert and then connect it this way. Very good. So when you run it, let's see what happens. You're going to see something like 1.00. So 1.00 still means that this is the R square. And what does it mean? It means that the values in the INQ is being explained by this and that 100%. Okay. So it can also be the case that you can have lesser value. It can also be the case that you have lesser value. So I'm going to delete PQ6 here. So let's see what happens. Let me run that. So you're going to have less than 1, right? Or less than 100%. So it means that whenever you run, you are doing the repeated indicator, and then you see that you don't have 100% or 1.00. It means that there is one of the items that has been left out. Okay. Don't forget that with repeated indicator, we move everything from any indicators, or all of the indicators from the subdimensions into the higher order construct. Okay. So when you run and you don't get 1, it means that something is wrong somewhere. So let me bring back the PQCs, and then this means that I have my all my components in it correctly. So now let's add another construct to it as maybe a sole independent variable, or maybe the behavior engagement. Here is it. So we can add this one as B, and let's treat that as a mediator. Okay. So let's hide this one. And then as a mediator, we have to connect this one to that, and then this one to this. Let's run and see. Okay, good. So now this is seen as a mediator, right? Good. So institutional quality is the higher order construct. AO, academic outcomes, our dependent variable. And then B is our mediator. So let's check the measurement model. Now we have, don't forget, this is reflective. And we have hide this one. That's why you don't see that. So let's show that. You can see that these are also reflecting, right? So now let's check the measurement again. Let me go to report. And let me go to my reliability. So let's check. We can check the loadings first. So the loadings are seen here. We have academic outcomes. So this is the sub-dimensions, and everything is green. The sub-dimensions of B, the indicators for the sub-dimensions are also green. And then digital access, the sub-dimensions are also green. Now, if you look at the INQ, it is showing red, meaning that the sub-indicators are not meeting the criteria. But let's take note with repeated indicator, we don't focus on measuring or assessing the indicators with respect to the higher order construct. Okay, so for example, with the construct reliability, if our higher order construct does not meet the criteria, that should not be a problem for us, because we are looking at, so for example, if the alpha was not met, okay, we check out for the alpha with the lower order construct. Okay, so it is almost likely that our ABE also will not meet the criteria. So first, we check the lower order construct from here. We check, assess the lower order construct. And once you are done, that's where you come in to check the higher order construct. So we can see from here, we have met all the criteria for the higher order construct. Is that correct? So what do we do? What we do is that we check, let's check the others as well. Discriminant validity has also been met. We are not going to focus on the IQ for now, INQ for now, because we are using the repeated indicator. So let's check for Fanalaka as well. This AO is bigger than any of the construct here. Same applies to this one. And this is higher than this. DA 0.893 is bigger than this one, right? And then same applies to this one as well. Same applies to this. Okay, so this one is smaller because of the loadings in here, because this is a repeated indicator. Okay, so that's not a problem. So when you are reporting, you exclude that. You are going to exclude that. So let's see how it's going to be done. So you just have to exclude these values. Because this is the higher order construct, and this one as well. So this is how we are going to report our values. This is it. Now, once everything has been met for the lower order construct, you go ahead and check. So let's check the VIF and see. So everything is less than 5. So we are good. And then the next thing you do, so let me run that again and then start calculating. if you want to check for the second order construct in terms of reliability, Chromacas alpha, and then the average variance extracted, and then the validity, we have what you call disjoint approach. So the disjoint approach, or the two-stage embedded approach, we are going to create the data. So first you run and then check or validate your first order construct. And we have done that because everything has been built, right, from here. So you go to open free reports and you create data. So the last time we realized that we were able to see our latent variables in here. So once you run the data or the algorithm, it calculates your latent variable. You can copy this and add it to your original Excel file, or you can create a new file. This time you have to ensure that we have latent variable score ticked. And the other variable that you can create in here, creating your case indices and next. But we don't need that for now, so you can just untick that. What we need now is the inclusion of latent variable score, as well as our manifest variable score. The reason why we are adding the manifest variable score is that you see with our model, we have only one subdimension, and then we have one higher order construct and then the mediator. And the mediator has its indicators as manifest variable. So you have to include that. Because if you don't include that, when the data is created, the manifest variables be missing. So let's check that, and then we can rename this as maybe NUGS tutorial dataset 1 derived HOC. So let's add the HOC so that we know that this is a higher order construct. About so let me come back. Now, once you come back, you come to data and select what you just saved. Okay, so I will select the NUGS tutorial dataset derived HOC. Then once you select that, you realize that the latent variable scores have been added. So if we unchecked the manifest variable, we are not going to see AO1, AO2, and the rest. Okay, but because we ticked that, because we checked that, that's why we see them here. So what are we going to do? We are going to have to delete these subdimensions in here, and at the same time, let's show these ones. We are also going to delete these ones in here. Okay, so just select that and delete, and then also select this one and delete. Now we have created a new data or new latent variable for the composites of DA. So this is DA. Let's bring it here, and then this is the next one was PQ, right? So let's bring it in here. So we can select and then we show that here. So these are now this is the second stage of our approach. So this is now the score, and it is serving as a reflective. Don't forget, we are doing reflective. So now, because we have the scores in here, we just have to maintain this as reflective. Assuming that we are dealing with reflective formative. Now we have dealt with the first order. So with the second order, we are supposed to invert it so that it will be formative, such that the arrows will be pointing towards the higher order construct. But we are dealing with reflective, right? So now we can change the labeling to maybe DA, LVDA, LVDA, LVPQ, right? So now we can run our PLS algorithm. Now we can see our measurement in here. So our AV is 0.516, and then alpha is very bad. Let's check that. So our alpha is 0.062, and then this is 0.062 and 0.679. Our AV is higher than the required. Okay, so I think this can be as a result of misspecification because we are using the existing data, trying to model it into this session that we are dealing with. Okay, but ideally, we check Chroma alpha for the lower order construct, so you don't have to be worried about the result that you see here. Okay, if you are dealing with the repeated indicator, our focus is on the lower order construct because we check reliability of our question that we have asked respondent based on the uh, the internal consistencies of the indicators or the measures. Okay. Now here's the case: we have converted the measure into another variable. That is why you can see something like this in here. Okay. So it happens this way. If it happens this way, you can only justify your case with your Chroma alpha, which is the first order construct or the lower order construct. So that is it. For let's check for the discriminant validity as well. So problem with this one as well because it means that there is a high correlation with PQ and then our digital access, which is D. It also correlates high with B. So maybe because of misspecification. That is it. So we can also check for the Fanalaka criteria. And okay, with this one, the difference between this and this is very small. So it means that BE and then AO also has a very high correlation with each other. Let's look at BIF and see. BIF are all met. So with this one, we are looking for the BIF of DA and then PQ. Look at this. You realize that it is 1.0, which is very low. So this indicates that there is probably a misclassification or something like that. And this is the RL square. So basically, that is how we go about with repeated indicator approach with the two-stage embedded approach, repeated indicator. Please, any question with this so far? Any question? Are you good?
Yes.
Okay, very good. So that is what I wanted us to look at today. Let me see if I can get, let me not save this. I have some existing data. Let me see which one of them. Okay, you can also see from here, we have multiple methods. Okay, so these are all data sets that we can use. Let me see. So let's look at employee retention. Okay, there's no data in here. So you have to select it before you see that there is data coming. So let's see this one. What kind of model is this? So I'm trying to open that. Okay, so very good. So what you can see here, this is a formative. And look at see this one, this, that, and this. Same way, this one, you come to form this. So let's run and see how it looks like. Okay, so that because we have this 0.5, it means that this is actually predicting that. This is predicting this. This is predicting that, and then that's okay. They are different construct altogether. So same way, Let's see. So we don't have any higher dimension here. So let's check the other ones and see. So this is European Customer Satisfaction Index, which is CSCI. This is supposed to show here. I'm trying to see. Once you click on it, it will have to show. So the O I has open here. But the organization, let me see this one. Employee retention. That one has not opened yet. Okay, let's see this one. Let's see. Organization very much more. Okay, so we have higher order stage 1. Higher order. So let's run this and see what is in there. So this is the first stage of the higher order. So these are the indicators. These are indicators, and this is predicting that. This is predicting that. So this is a mediator, and this is also predicting this, predicting that, and the mediator is also predicting this one as well. Okay, so let's look at the stage 2. So let's see what we have here. We have OP, OI, and then AC. Now let's check this one again. So OP, OI, and AC, or was it AC? AC. So that means they've converted this one. Let me see what they did here. So what they did was that the dependent variable that we saw here. So this is what they've done. They have converted this to ACJ and then ACL into a dimension which they term it as AC. All right. So actually what they did was that this OP is predicting that, and then OI is also predicting a sub or it is predicting a broader concept, which is AC. And the AC has a dimension called ACG and then ACL. All right. So what did they do here? First, you have to run and then create your data. Is that correct? So you have to create your data. And then when you come here, so let's see whether our data is created. So you have the latent variable score, ACG for this one, ACL for this one has been created. Now, they just, with the second one that they did, they had to delete these ones. All right. And then what did they do? They created a new latent here, and then they called it AC. And then they moved in this one, and that's into this one. And then they connected this to that, this to that, and then you run that. So let's see, was it formative or not? So let me save this one and come back later to that. Okay, so they were all formative. So you see, the R square is 0.406, and that is the exact same thing that they have. We have negative 789 here. Let's check the one that I run in the stage 1. So let me run again. Don't forget, the data has been selected already. So data derived from PLS-SEM. So it's already selected. I'll just have to run that PLS algorithm, and then the same results 0.406, 0.788, negative, and then 0.915. So that is how you go about higher order constructs. Any question so far? Any questions so far? That means you are good. Okay, that is fine. Let's see this data. So we can explore with these data sets that we see on the menu or whenever you on the workspace, whenever you open some, you see this, you can always explore with them. So this is OI moderated mediation. So here it means that there is a mediator, which is this is the mediator, and then it is being moderated. So this is a moderated mediation. So let's see, and let's run it and see what we can see. Okay, so very cute and nice. Let's check the reports. Okay, so here the Kumak alpha did not meet the criteria. Is that correct? And then let's see what else. Discriminant validity. This is okay. Let's see for Naraka. And this is also okay. So what can we do to solve this issue? So let's see ACL. Where is ACL? Let's try and see if we can delete some of them. Because everything that we see here is reflective. So the lowest one is AC love 2. So let's try and delete that and see and run again and see what happens if it will improve. Okay, so I don't know if it has even come down. Now it is 0.592. I think previously it was higher than that, right? Okay, so that means you don't need to even, because once you do that, it will even make it worse. Okay, so basically the the composite reliability we'll see has met the criteria. I think the last time I explained that with PLS-SEM, the focus is more about composite reliability because of the weight that has been assigned compared to the traditional one that we use SPSS to calculate. The SPSS normally give us the composite score. We normally use the composite score, but with the STEM, we base on the composite variability because of the weight that is assigned to each of the indicators or the loadings. And for that matter, we normally focus on composite variability, row C or the row A. All right. Okay, so you can report this and then justify why this could be the case. Probably that is how the data is behaving or exhibiting. All right. So this is one of the examples in there. So there are a lot of examples that I think you can practice with. So any question at this point? I think we can call it a ninth. Then we continue tomorrow. Probably tomorrow will be the last day for the session. Okay, tomorrow will be the last day for the session. So is there any questions so far? Any question? Are we all good? Hey, am I the only person on fire? Check.
Yes, Doc. Doc, we are good.
Oh,
We are
okay.
here. Yeah, we are here.
We are here. Is it difficult or it is okay?
Oh, it's okay.
It's
Yeah.
okay. Or is it becoming difficult?
Yeah.
You can also combine PLS-SEM with we have what we call necessary condition analysis. So this paper is very good. You can download that and read more about it. Okay. And then which paper again. So far, I've not published any paper that I've combined PLS-SEM and then NC. It is still under review, so maybe when it comes, I'll also share it to you on the platform. But let's look at this paper. Okay. So basically, the idea with necessary condition analysis is that with the PLS that we have been doing, the assumption is that each of the constraints are sufficient to predict the outcome. Okay, they are all sufficient. But what we want to find out is any of the construct necessary? Is there a necessary condition? Is it supposed to be the case such that the dependent variable will have to exist, something like that? So that's why we call necessary condition analysis. And you can also use SEM, the Smart PLS software, to do that. So let me open this paper and then let's see what is inside. I think our time is up, but if you are interested, then we can go through this quickly. So they used PLS-SEM, NC, and then they combined important performance map. I think we did this one last week. So this is another aspect of SEM that we can also look into, combine important performance map analysis. So that's what they did. So let me go to the NCE aspect. NCE. So in step 6, researchers to run the NCE in order to identify potential necessary conditions. The NCE can be conducted with free R package. You can use R to do that. And then you can also use the Smart PLS-4 to also do that. So this is the basic outline. The NCA draws on the endogenous construct, that is the dependent variable, and then the direct antecedent latent variable, as well as the potential indicator score if there are formative measurements as explained by Richard and then the rest. NCA could offer the input data empirically, or the input data is empirical or theoretical scope. In the NCA context, general recommendation is to use the empirical scope as it produces more consecutive estimation. So what do we look out for? Creating bottleneck. So we have what we call bottleneck. We have to create a bottleneck table. Okay, so it helps researchers to assess the identity cognitive importance and then performance. A bottleneck table is a tabular representation of ceiling line. So the first column of this table displays different level of outcomes, while the next column of columns display the condition or conditions corresponding levels. All right. So let's see. It ranges from 0% to 100, and we can use the SEM to do that. So what do? We evaluate the reliability and validity of our measurements, and then we are focusing on NCE. So what do? We can use NCE to do that. Create a bottleneck table, choose the desired level of target construct, and then interpret your findings. So I think this one, you combine 3 approaches: the combined IPMB, the PLS-SEM, and then the necessary condition analysis. So this is also very simple to go about. Maybe tomorrow we are going to dive much into that, but we can find it in the regression side here. So you can see that we have regression. So once you have modeled your analysis and you are done, you have created your model. So this is what we did before we closed, right? So now we have created the model as well. This is the NUGS tutorial dataset. So this is the derived table or the derived dataset. So you can find the NCA in regression. Okay, so you can just name it maybe NCA analysis, and then it will open for you. So here you're supposed to also create another model. So let's assume that our academic outcome is our dependent variable, and then you want to assess whether each of these antecedents. Okay, so in the field of NCA, we call the independent variable antecedent. So what do? You just take, you just drag and drop it inside the dependent variable. So it will create it for you, and then this one as well, this one, and then this one as well. So this is the intercept. You just have to run. So here you can run regression. Okay, the normal regression that we know, SPSS. So this is the regression. The R square is 0.615, and then you can see the standardized or standardized summary and over coefficients with Pagan test, collinearity statistics. But what we are doing right now, if you want to also find out the significance, you go to Bootstrap, right? And then you just calculate. So let's see, and we go to open for reports. So you can check the p-value for standardized. This is it. They are all significant, and these are estimates. Same way, our standardized coefficients, you have them here. Also significant, R square, VIF, and then adjusted R square. So let's run the NCA. You can also perform logistic regression. Okay, so this data is not suitable for logistic regression. So you cannot do that because we require a binary independent variable. If you want to perform logistic regression, your dependent variable has to be binary, maybe male or female, or you can assign codes. Let's say 0 means presence, 1 means otherwise, something like that. So it has to be categorical in nature. And this is the necessary condition analysis. So we just start to calculate. Let's go to open full report. So we have our ceiling regression. Okay. So this is the C is ceiling envelope, and then C are ceiling regression. We have the details in here. This is the bottleneck. Let's show the bottleneck in here. So probably tomorrow I'll throw more light on these, and if you're interested, you can also write papers on that. Because if you combine these two, I think your paper, you're able to give more insight for the researchers or the reviewers and then the policymakers as well. You also see the plots. So probably you might have seen this kind of plot somewhere, but this is it. This is it. So this is the NCU plots, right? So the line here is the ceiling regression. Then the CE is the ceiling envelope, right? So let's see what we can do tomorrow, God willing. Thank you very much for joining, and I'll pause the recording for now.